All right, this is Stewart Calculus, 8th edition, section 1.1, problem 12. Problem 12 reads, trees grow faster and form wider rings in warm years and grow more slowly and form narrower rings in cooler years. The figure shows ring widths of a Siberian pine from 1500 to 2000. So there are two parts to this question. There's part A and part B. Looks like part A asks, what is the range of the ring width function? Well, the range is the y direction, right? So it looks like it gets really close to 0, maybe 0.01, 0.05. I don't know. It looks like it gets very, very close to 0. So we can estimate that range as maybe something like 0.02 or 0.03. We'll just say 0.02. 0.02 all the way up to right around 1.6. It's a pretty big range actually for millimeters with the ring width. And then part B, it says, what does the graph tend to say about the temperature of the Earth? And I guess they wanted to throw in a bit of trivia here because it says, does the graph reflect the volcanic eruptions of the mid-19th century? And I guess so, because in the mid-19th century, right around here, we start to have these volcanic eruptions, which I don't know if that would make it hotter or colder. Maybe colder because the Earth could be covered in a little bit of a blanket. It's kind of a strange question, but we could say that the temperature tends to be consistent all the way, relatively consistent until about 1900 or the late 1800s, and then it spikes up. So maybe we could say the temperature decreased slightly from 1500 to 1700. Then had a spike in the late 1700s. After recollecting in the late 1800s, it has increased ever since. Or consolidating, maybe. And there we have it. So what we can say about this graph is the temperature decreased slightly from 1500 to about 1700, then had a spike in the late 1700s. After consolidating back down in the late 1800s, it has increased steadily. And those words seem to describe the graph pretty well. So we'll leave it at that, and that's going to be it for problem number 12.